Right, with this partial fraction, the slip you are likely to make is not to recognise that we have a repeated factor as part of the denominator. So this x squared means that that is the repeated factor of x. So when we write this out to get started, the starting point is a constant over the lowest form of that factor, which is x, plus another constant over the x squared, plus a final constant over the linear factor 2x minus 1. So that would probably be the first place where you would trip, is not spotting the repeated factor and maybe putting that as bx plus c. So now we combine the right hand side of that equivalence, and we know that it's all going to go over that combined denominator. So when we divide x into that, it'll cancel with one of the x's, leaving you x 2x minus 1. So it'll be ax 2x minus 1. If we divide the x squared in, it leaves us 2x minus 1. So we'll have the b constant 2x minus 1. And c, when we divide that in, we're left with the x squared term. So they're equivalent, which means the numerators must also be equivalent. So therefore we can say that x plus 1 must be equivalent to ax 2x minus 1 plus b 2x minus 1 plus c x squared. If we expand the brackets on the right hand side, we get 2ax minus ax plus 2bx minus b plus c x squared. And I can see that I've slipped there. That would be 2ax squared. Right, if we form some simultaneous equations now by comparing coefficients on the left and right. X squared terms, there's no x squared term on the left. On the right we have 2a plus c. So if we call that equation 1, then the x only terms, x to the power of 1, we have 1 on the left hand side, and we have a minus a plus 2b on the right hand side. So that's equation 2. And then the number only, x to the power of 0, I have a 1, and that's going to be minus b. So therefore b is minus 1. If I put that into 2, 1 equals minus a plus 2 lots of negative 1. So a will be negative 3. And if I put that into equation 1, we get 0 equals minus 6, minus 3 times 2 plus c, so c equals 6. So therefore x plus 1 over x squared 2x minus 1 is equivalent to, so the only positive one is 6c, so I'll start with that one just to make it look neater as I write it. 6 over 2x minus 1 minus 3 over x minus 1 over x squared. Okay, so there were 5 marks for that question, and in order to earn those 5 marks, there was 1 mark for correctly getting it into the form, the combined form with the constants in. There was 1 mark then for the method of equating or the equivalence of the numerator, and whether you chose to go down the simultaneous equation route or choosing values of x route. That would be the method mark for that. And then there were 3 marks for each of the calculated constants, giving you the 5 marks. So that was that question. And then the second question was a binomial expansion. So let's take a look at that now. So remember, that's not part of the question, that's the standard format of the binomial expansion which you're given in your MEI formula book. So the question's here: given the binomial expansion 1 plus qx to the power of p is equal to that, so they've performed the expansion for you, find the values of p and q. Hence state the set of values of x for which the expansion is valid. So if I have that, then I need to expand up and including the quadratic into there. So it'll be 1 plus nx, well, n is p, but x is all of that, so that should be pqx plus n minus 1, so p minus 1 over 2 factorial, times x squared, which would be in our case qx, all squared. I don't have to go any further. So now all I need to do is compare the coefficients. So 1 is 1. PQX must be equivalent to minus x, which means PQ must be equivalent to negative 1. So the x term, PQ, must equal minus 1. And then the x squared term, we will have the p minus 1 over 2 factorial, q squared must equal plus 2. So just to tidy that up a little bit further, get rid of the fraction, and I'm going to have p minus 1 q squared equals 2 times 2, which is 4. So those are my 2 equations. Now I'm going to rearrange that to eliminate a variable here. If I choose to eliminate p, then I'm going to be introducing further products of q. So it's going to be better to rearrange 1 to give q equals minus 1 over p. And then if I substitute that into 2, I'll have p minus 1 over, and when I square that, it'll become plus 1 over p squared equals 4. That p will cancel with one of those, which I'll then multiply up to get rid of the fraction. So I'll have p minus 1 equals 4p. So 3p is negative 1. So I take that p over there and it becomes a subtract. So p is minus a third, and I then put that into equation 3. Q equals minus 1 over minus a third, which will become plus 3. So that's a slightly different binomial expansion question to the previous ones we've looked at, but hopefully one that you can get your head around all right. 6 marks for that question. 1 mark was for that expansion, or that part of the binomial expansion, and then there was a 2nd mark for that part of the binomial expansion. There was 1 mark for ending up with an equation with only one unknown in, so for eliminating either P or Q. There was an answer mark for minus a third. There was an answer mark for 3 for Q, and what I haven't realized is I haven't completed this question because we've got to do the validity as well. So for the validity, so what we've got is 1 plus 3x, because Q is 3, to the power of minus 1/3. So that's the expansion that we're working with, and we know that it's valid, sorry, off the screen, for the modulus of the x term to be less than 1. Well, our x term is 3x, so it's valid for that, or you can't leave it like that, you need to get the x on its own. That's forcing it to be positive. Well, the 3 is positive because it's a constant number, so you end up with the modulus of x being less than a third, or if you prefer and not use modulus, that means the same as that the 3x must take a value between minus 1 and 1. So if we divide by 3, we get that. So either of those is an acceptable answer, and there's an additional mark for that validity. So there should be 6 marks there. 1, 2, 3, 4, 5, 6. So there you go.